this assignment with you again on video and talk about each question that's not correct to help you fix it. But I really want to make sure that you understand something about QSI and grading, and what we really need to make sure is that what I've been asked to do, which is I'm paid, my job is to teach in QSI's system. And I want to try to explain why I think that my job isn't necessarily matching your goal right now. And if I can help you kind of think a little bit differently about how you're turning in assignments and how you're thinking about your assignments, then you and I might be working on more on the same page. So just real quickly, I brought up the syllabus here. It says, mastery means that a student has learned the facts or concepts to such an extent that they are usable tools in future endeavors. Well, that means to me that whatever it is you've done in a lesson, right, whatever the TSW is, not that you just do it once and turn it in and are finished, but that you can use it. So when I have different projects or different things at the end of the test, what I'm trying to do is see, did you remember well enough what you learned in the lesson so that you can use it later? And how do I think this isn't matching your goal is that I really feel like your goal is to turn things in, right? And as soon as they're turned in, then I should accept them as being finished and you should go to the next assignment. And so we're not really working on the same page. My goal is that you are able to use these mathematical skills, both in the assignments now and in the future, and your goal is to finish them. So somehow, if I can get you to have the goal of learning these things and really knowing them and feeling like you can remember them, then you're gonna finish. So that goal will just kind of take care of itself. So it's kind of like, what are we looking at? And I'm hoping I can get you to switch to looking at and asking yourself the question with everything you're doing, do I really understand this? Can I use this in the future? Instead of saying, I need to finish this to be done with it. All right, so let's go through. This is what was turned in. This is the last one turned in. And let's kind of go through what I'm seeing here. And you can pause it to go back. All right. This one, these two, you can see how it's, I know you know this because you told me, so I'm not so worried about one. Graph the function, you can see that what's here is not a graph. So, you can print this and write on it. 3 is done. 4 is done. 5, we worked on this together. It doesn't make sense. 5, we talked about putting 60 into the function, right? To plug 60 in and see what value. And what they're asking you to do is what height you get. Here's the height of Mount Everest. So can we really say that this goes all the way to 60 seconds? Does that make sense? That's what you're trying to answer in question 5. And then if it doesn't make sense, how the domain in this instance is how much time. So how much time should I have so that this function makes sense to be a roller coaster? How many seconds? 0 is a good start, but we can't go up to 200 seconds because we're going to see how high it is at 60, right? And I showed you how to do this one on Teams. We put 60 in, 60 cubed times 0.3 minus 5 times 60 squared plus 21 times 60. What is that height? How does it compare to Mount Everest? Right? That's the first part. That's what it means to evaluate h of 60. And then you're going to say, well, how long can this be a roller coaster? All right. Cubic, we talked about this one too. Go back and look at something. If this has 1, 2, 3 turns. Find out, can a cubic polynomial just have 3 turns? Or does a cubic polynomial have 2 turns? How many turns per function? So we need to fix that one. All right, 7 is good. 8, you colored it correctly. You have, it says use your graphing calculator relative min and max. Okay, so if this is the function, this is a relative max, this is a relative min, this is a relative max. So if they're asking you to find all 3 of these, you don't just have one answer here, you have 3. The end behavior is up and down. That's what you wrote here. Well, You have right now an end behavior. This is fourth degree polynomial. So is a fourth degree polynomial up and down? The down part is, but this part's not up. So think about the end behavior of a fourth degree polynomial. You have to think about 10, 11. I think this ride would be very small. It would mean that the ride is very slow. A 2-minute ride. Well, in this function, you have to graph it and ask yourself, if this just goes 2 minutes for a roller coaster is a pretty long roller coaster ride, being a person who's rolled lots of roller coasters. But what you need to look at is the graph. It's not about it being slow for 2 minutes. It's asking yourself, if I have t in minutes, does it make sense, right, for a 2-minute ride? So what happens between 0 and 2 on this graph? Does it go, it's just like thinking about this question. Does it go up too high in that 2 minutes? Does it go way far underneath the ground in 2 minutes? All right. For question 12, I sent you a video on how to use synthetic division to do this question. All right, so you need to watch that video. It's on Teams. I'll even bring up your Teams here. We can look at it together. All right, this remainder theorem. So it's right here. It's very recently in Teams. The remainder theorem is going to show you how it helps us do this evaluation process faster. Please watch that video. And then if you try, you can show me your work to see how far you get on that. That's question 12. Now we can go to the next one. All right, so we have, this is a cubic function, and right here you have something graphed that is not cubic. This looks like a quadratic. So you need to look at how this is graphed. It says, what is the model practical domain? It says, why do you think? So you said, because otherwise the roller coaster would get too tall. Okay, that makes sense. I'll take 14. At what time is it 50 feet? You have 15 right. That's done. 16, the rational zeros test. These are not all the possible zeros. These are the actual zeros, right? You need to go back into the lessons or look it up. What is the rational zeros test? Because this is asking you not for the actual zeros, but for the possible zeros. All right, so go back and find the rational zeros test, write all the possible zeros. Okay, so are the zeros where they're going underground? I'll take those. If these are the real zeros, let's so 17 is okay, and there are no non-real zeros I can find in this polynomial. This is true, but why? Actually, no, we have to go, wait. We have a cubic function here. So a cubic function should have how many zeros, right? We have to account for, if it's a cubic function, we have to account for 3 zeros. So we can either have 1 real zero and 2 non-real, or we have to have 3 non-real zeros. So let's just double check this function in Desmos right now. Let's see what we got here. So we have y equals negative 2x cubed plus 23x squared minus 59x plus 24. All right, and we can clearly see right now that the zeros you have listed, right? I can see these zeros on here. They're not the zeros that you have listed on your assignment. Where'd that assignment go? Here we go, right? They're not at 0.3 and 0.23. So double check, right? Maybe you did not type the function incorrectly. And we can also see, let's double check 50 feet, right? So 0 to 8. No, we were working with this function. Sorry, we didn't need those ones. So we're working with this function. We can see that these are not the possible zeros. So this isn't asking you for the actual zero. This one's asking you for the possible. and this one is not correct. And then you have to think, can you actually see non-real zeros in a graph? You cannot. But because I can see 3 actual zeros, I have accounted for the fact that this is a cubic function. All right, so I hope that helps you with this assignment. If you're stuck on any one question, send me, tell me I'm working on 16, show me what you've tried so that I know you've gone back, you've looked up what the rational zeros test is, and you're showing me with this assignment that you're able to use everything that you learned in Unit 3.